Hello, and welcome to the Senior 2 Medication Calculation Practice Questions. As before, we will continue to follow these guidelines below. Questions 1 and 2 are based on the following order. Your 65 kilogram patient has dopamine ordered at 6 micrograms per kilogram per minute. Available is dopamine 400 milligrams per 250 mL NS. How many milligrams of dopamine per ml of fluid are running? What is the concentration of the drug? So basically, what they're asking for is the final units are going to be in milligrams per ml. And you have this bag of dopamine, and there's 400 milligrams per 250 ml. And so what we're trying to find is how many milligrams per 1 ml. So you're going to go ahead and do 450 milligrams divided by 250 mLs. And the answer is 1.6 milligrams per ml. So that means in this bag of dopamine, for every ml, for every 1 ml, there is 1.6 milligrams of dopamine. Number 2, what is the IV rate round to the whole number? So there's a specific formula that I want you to memorize, and I'll go ahead and write it down. So you're going to go ahead and make sure that you have micrograms per kilogram per minute multiplied by kilograms, and that's the patient's weight, times minutes per hour, and that will be 60 minutes per hour, over micrograms per ml. And this is a formula that you have to remember, and this will give you the answer in the final units of mLs per hour. So let's see what we have. Did the equation give us micrograms per kilogram per minute? Yes, it did. There are 6 micrograms per kilogram per minute. Did the problem give us the patient's weight? Yes, it gave us the weight, 65 kilograms. We know that this is going to be 60 minutes per hour because that doesn't change. And did they give us micrograms per ml? Well, in number 1, we figured out milligrams per ml. And because we figured out the milligrams per ml, we can go ahead and convert it. And the conversion that we need to know is there are 1,000 micrograms per milligram. So let's go ahead and do the math. 1.6 milligrams per ml. You want 1 milligram in the denominator, so the milligram units cancel. 1,000 micrograms in the numerator, and you get 1,600 micrograms per ml. So yes, we do have micrograms per ml. And I like to write everything down on this side of the page, as you can see, so that I can just go ahead and do all the math. So using this equation, we're going to go ahead and multiply. So we have 6 times 65 times 60 divided by 1,600. And the answer is going to be 14.6 mLs per hour. But we're rounding to the whole number, so that'll be 15 mLs per hour. Questions 3 and 4 are based on this specific order. Nitroprusside 0.4 micrograms per kilogram per minute is ordered. The patient weighs 80 kilograms. Available is nitroprusside 50 milligrams per 250 mLs in NS or normal saline. What is the concentration of the bag? So let's go ahead and write out what we're looking for. So remember, we have this bag and it has nitroprusside, and there's 50 milligrams of nitroprusside in this whole bag of 250 mLs of NS. So remember, what we're looking for is how many milligrams per 1 ml. And we're going to go ahead and box that. So 50 milligrams divided by 250 mLs. And our answer is 0.2 milligrams per 1 ml. And let's just go ahead and move forward because we know that we have to change this into micrograms later. So remember that there's 1,000 micrograms and 1 milligram. So let's go ahead and rewrite that. 0.2 milligrams per ml, 1 milligram. So your milligram units cancel. 1,000 in the numerator, and you're left with 200 micrograms per ml. But our final answer for number 3 is going to be 0.2 milligrams per ml. Number 4, what is the IV rate round to the whole number? So remember, we're going to write down our equation again. Micrograms per kilogram per minute times the patient's weight in kilos times 60 minutes per hour, all over micrograms per ml. And that'll equal mLs per hour. So make sure you memorize this equation. So let's see what we have. Did the problem give us the micrograms per kilogram per minute? Yes, 0.4 micrograms per kilogram per minute. Did they give us the patient's weight? Yes, 80 kilograms. Perfect. Did they give us, we know that 60 minutes per hour, and we already figured out the micrograms per ml right here, 200 micrograms per ml. So let's make sure we write that. So we have all our numbers all available. So the way that they could change this problem is they can give you the patient's weight in pounds. If they give you the patient's weight in pounds, you just convert it into kilograms. And then we already know how to convert from milligrams per ml to micrograms per ml. So that's a different way that they could ask the question. But let's go ahead and do the math. That's 0.4 times 80 times 60 all over 200. And the answer we get is 9.6 mLs per hour. We're doing it to the whole number, so it's 10 mLs per hour. Questions 5 and 6 are based on this information. Dopamine 400 milligrams per 250 mLs NS is running at 26 mLs per hour. The patient weighs 70 kilograms. So let's determine the amount of medication per ml. So remember, we're just looking for milligrams per ml. And we did this earlier in number 1. But remember, we have dopamine, and there's 450 milligrams of dopamine, all in 250 mLs of NS. So we're going to do 400 milligrams, 450 divided by 250 mLs. And your answer is going to be, again, 1.6 milligrams per ml. Remember, the conversion that we need to know is there's 1,000 micrograms per milligram. So rewriting that, because we're going to need it to figure out our ml, to figure out number 6, is there's 1 milligram, 1,000 micrograms, and you have 1,600 micrograms per ml. But remember, our final answer for number 5 is going to be in milligrams per ml. But we already did the extra work and found the micrograms per ml. So number 6 is asking how many micrograms per kilogram per minute is your patient receiving? So let's go ahead and write down our equation. Micrograms per kilogram per minute times your patient's weight in kilos times the minutes per hour, 60 minutes per hour, all over micrograms per ml equals the mLs per hour. So remember, this is the formula that we're working off of. So let's see what we have. Do we have micrograms per kilograms per minute? No, because that's what they're asking for. So I'm going to go ahead and put that in a different color. So this is what we're looking for right here. And do we have the kilogram of the patient? Yes. 70 kilograms. Check. Do we have the minutes per hour? Yes, because it's always 60 minutes per hour. Do we have the micrograms per ml? Yes, we do. 1600 micrograms per ml. Perfect. Do we have the mLs per hour? Did they give this to us? Yes. 26 mLs per hour. Okay, so let's go ahead and use, we're going to figure out micrograms per kilogram per minute, and we're basically just going to call that X. So we have X here, and it's going to be multiplied by the patient's weight, which is 70, multiplied by 60, all over 1600 equals 26. So since we're figuring out for X, let's go ahead and rewrite the equation. So we have 1600. So we have 26 times 1600, all divided by 70 times 60 equals X. And the answer is 9.9 micrograms per kilogram per minute, and this all rounds to 10. So final answer for number 6 is 10 micrograms per kilogram per minute. Number 7, Decadron 2 milligrams IM, Q6 hours is ordered. Available is 4 milligrams per ml. How many mLs would the patient receive? So our final units that we're looking for is ml. The order is 2 milligrams. What's available is 4 milligrams per 1 ml. You're going to do order times available, 2 milligrams, and you have 4 milligrams over 1 ml, and your answer is 0.5 mLs because your units of milligrams cancel. So final answer for number 7 is 0.5 mLs.